Okay, so I'm gonna do this one more time with you. Okay, so go to page 28. Kite is its own little island. Okay, so kite is like in the middle of that tree that I showed you. So all you need to do is, it's a stacked isosceles triangles. Okay, this is on page 28. But you have to make sure that the top triangle is shorter than the bottom. Like, you got to make sure you understand that. So there are your two triangles that you stacked. And so one of the properties would be talking about the side lengths that are the same, that measure the same. So that'll be one property. Two pairs. I'm going to be very short and sweet here. I'm going to use a lot of symbols if I can. And the other one would be, you could say that this angle is the same as that one. Okay, one pair of congruent angles. Boom, you've got it. Could do another one. You could say page 28. Okay, the diagonals meet at a 90. Watch, I'm just going to use this. Diagonals meet at a 90. And short diagonal bisects. So that would be just making a mark on each side. Like that. That's also one. So I'm just going to leave it at that. I'm not going to give you the three versions. I just wanted you to practice that. I technically, on this here, I have 4 properties right there. So maybe that's all you need on your study sheet, just to have like 2 different kites with different properties, and you've got 4. More than 4 is overkill, right? Like, I think that you're going to be okay with 4. A right trapezoid, I think all you need to make sure that the shape resembles what it's called, right? So a right trapezoid, you would want the right angles clearly labeled, and you would want the arrowheads like that. Two right angles, one pair of parallel sides. That's it. That's all you've got for that one. Parallelogram. It's like, right, the root of all these shapes, except for the kite, of course. A parallelogram looks like a slanted rectangle. Like that. So one property, I think, right, the top and the bottom are going to measure the same. So are the sides. You can also say that the top is parallel to the bottom, and the sides are also parallel to each other. Very busy, I know, but 2 pairs of congruent sides, 2 pairs of parallel sides. One more. We can talk about the fact that this angle is going to be the same as that one. and this angle over here is going to measure the same as this one here. I would like to insert the diagonals as well. So the diagonals like that. Are they going to measure the same? No, they're not. There's a long and a short. Just remember that. But they bisect each other. So this stretch to the center is going to be the same. It's not the center necessarily, but to where they meet. And so the other diagonal is also going to be cut. So one pair of congruent, sorry, two pairs of congruent angles and diagonals bisect. Okay. And you're going to have to practice this because it could be, in a sense, two easy marks. Because when they've done that before, when they ask for two properties, all you have to do is make sure the two properties show up, and you got 2 marks. And that's that. All right. What's our time? Let's go to 30. So I will say this on 28 before you flip. I'll just say homework page 29. I'll say 28 to 29 even though we've already done 28. But this is specifically just sketching. That's all it is.
Do we need to do 3 or 2?
I would say try 3 just to practice. But really on the exam they're going to ask you for 1 and make sure it has 2 properties or 3 properties, whatever they may do. There could also be true or false with geometry. I can see that happening. Okay, so you just have to know multiple choice. They may say parallelogram has, right, 1 pair of congruent angles, 2 pairs of parallel sides. You're like, wait a minute, there's 2 congruent angles. Why is it saying 1 pair? So it's not quite correct. And so you just have to know your properties. Let's go to 30. I will say this. Anytime in these following pages, listen carefully, when I ask you to find the area, we're going to omit that. I'm going to make that optional to you. So if you're interested, you have the formulas. You know that you have to find the height. Remember, you know sine law and cosine law at this point. You know Pythagorean theorem. So you're able to find the height somehow if needed. But we're going to keep it, we're going to focus a bit more on the very basics here. So given the quadrilateral below, so you look at this, what type is it? Like what classify this shape if you had to? And what would you say? It's definitely a trapezoid, correct? It's an isosceles trapezoid. Why? You see, this angle is the same as that angle, correct? That is the giveaway. Okay? So this is an isosceles trapezoid. And the reason I went with isosceles is because the base angles are equal, are congruent. That's how I knew for sure that this is an isosceles trapezoid. Okay? All right, so that's a very classic question, by the way. Determine the values of angle A and angle B. Let's do that. Angle A. What would this one be here? You remember what I did on the diagrams? What did I tell you these two always add up to? It has to do with parallel lines, by the way. That's why that is true. So all we will do is 180 minus 60, and that is equal to 120 degrees. What about angle B? This one up here. It's going to be the same, right? It's 180 here as well. So you just go 180 minus 60, it's 120. So they're both 120 degrees. What is the length of side AC? This one right here, like AC is talking from there to there. What would you say? Don't overthink it. Just look at the diagram. AC is right here. It's going to be 4, yes, because it's an isosceles trapezoid. AC is the same as BD, which is going to be the same as 4 centimeters. Okay, so you're like, what kind of gibberish is that? Just make sure you tell me that it's 4 centimeters, and then you're good to go. So these types of questions, you can expect that on the exam. Is there going to be a whole lot of these? If you went through the exam, there isn't a whole lot of geometry, but it does sneak in here and there. So it might be 2 marks here, or 3 marks there. You don't want to get those wrong, if at all possible. For those of you who are interested, some of you like the challenge. Calculate the area of the trapezoid. I give you the area right here. You need the height. Right? Find height of this thing. How would you do that? I'm just going to give you the how-to here. Are you ready for this? This might be fun. Or not. Okay. What you need here is you need to cut this triangle right here. You can pick either side. I'm going to pick this side right here. And you somehow have to figure out this piece right here. Because this is the height. And this is x. Let's call this x. So let's cut that one out. Put x here, h there, 4 there. It's a right angle because it's the height. How can I find x? There's a way to find x here. I'm going to show you that we're cutting both ends. We're going to cut both of them off. So what I will do is I will go 9. I'll take the 9. And I'll subtract 5 from it, so that middle piece right here. And I will divide it in half. So if I take 9, I subtract this 5 portion from it, then I split the remainder evenly between these two, and that's how I get x. So x is equal to 4 divided by 2, and that's 2 centimeters. And that's what x is. That's how you find it on a trapezoid. And how would you find height in this case? If you've got 2 out of the 3 sides, what do you use if it's a right triangle? Pythagorean theorem. That's correct. Okay. And some of you might be looking at this like, Mr. Dirksen, I knew that this corner here was 60. Couldn't I have used sine law for this? You are correct. So whatever method you choose, you go for it. Okay, it will work. I will use Pythagorean theorem here. H is one of the legs, correct? So you have to go 4 squared minus 2 squared. And that gives me root of 12. The height is going to be 3.4641 centimeters. Why are you using 4 decimals, Mr. Dirksen? Because I'm not done yet. I want to try actually to use all decimals if possible to find the area of this trapezoid. You know what? This might be a bonus or something like that, so I'll do 1 at least. You got it, right? You found the area, the height, sorry. The area is therefore, what does the formula call for A plus B? What does A and B stand for? If you look back a couple of pages back, A is the top here, B is the bottom. So I'll do it one more time here. A, B, and this is the height. Those are the 3 pieces you need to figure out the area of a trapezoid. So A is 5, B is 9, make sure you put that in brackets, times the height. All of that divided by 2. The area in this case is 24.25 squared centimeters. I've never seen one like this on the exam, and as far as I know, you're not required to know how to do the area of a trapezoid. I still do it because I think it's a good skill just to do the calculations and be thorough with your work. But I'm going to leave it there. So whenever it's asking for area, don't worry about it. So I'm going to ask you to work all the way to page 32, and that's where we're going to end today. I will just say this, areas are optional. So whenever it's asking to find the area, you can say, you know what, I'm going to leave this for now. I'm going to focus on everything else before I do the areas, okay? All right, that's it for today, guys. And then tomorrow we'll start polygons.